Alright, it takes 4.71 joules of work. So this is our elastic potential energy. And it takes that much energy, that much work, to stretch the spring a certain distance. And so we're going to say this distance is x1. Well, technically x0, the original displacement of the spring. Alright, how much extra work is required? So it's asking for additional work, not the total work. So pay attention how much extra work is required to pull it an additional. So this is not a new length, this is an additional length, so we'll call this x1. Okay, so let's start off with the equation. So we know that the elastic potential energy is 1/2 k, which is our spring constant, times x squared. In this case, we know what the energy is, we know what the x is. What we do not know is the value of k. So before we can do anything, we need to solve for k under the original conditions. And to do that, k, if I move this around, is equal to 2 times the elastic potential energy divided by x squared. Alright, so we just got to plug our numbers in. 2 times, my number is 4.71, divided by, we have a conversion here, so that would be 0.075, and that's our stretch squared. So it does have to be in meters. Make sure you do that conversion by dividing by 100. Alright, so what that means is that our value for k will be equal to 1675, and the units for the spring constant are newtons per meter. Now, that's not our answer, that's just a means to an end. So now we need to look for our new condition. So under our new condition, so let me change to blue ink, we have a new elastic potential energy, so I'll call that US1. And so that is equal to 1/2 of k. And we just solved for k. My number for k was 1675. Multiplied by x squared. Now, the way the question's worded, we're pulling it back the original 7.5, but we're also pulling it back an additional, it would help if I also converted it, 0.075. But we're also pulling it back an additional, and I need to convert that one to 0.0834, and that is squared. Okay, so when we plug this into the calculator, it'll spit out an answer of 21.01 joules. So to pull it back, the original distance was only 4.71. To pull it back an additional an additional 8.34 centimeters would require a total of 21.01 joules. That's the total. Now, if you think that's the answer, you would be sorely mistaken, and you would get that question wrong. So there's just one last step here. it's asking for how much extra work is required. So it's asking for the additional amount of work. So that additional work was equal to the change in the energy. And in this case, our change in energy is equal to the change in elastic potential. So I know I keep adding equal signs here, but I'm just expanding it out. There are a lot of ways of saying it. So this is our final elastic potential energy minus the original elastic potential energy. And we know both of those numbers. The final is what we just calculated. That is the 21.01. And the original that we started off with is the first number that we were given. And that was the 4.71. So what the question is asking for is the difference in those two energies. And that would be equal to 16.3. And that would be our final answer. So always pay attention to how the question is worded.